Hey, welcome back. We're building a RANS S21. Let me discuss for just a little bit of what's going on. As you probably noticed, or I haven't put a video out in about 3 months. I actually got to a point in the build with the engine and the ignition and some of the wiring that I wasn't feeling 100% confident, and I was doing a lot of research and not moving very far with the build. And so I finally asked a qualified friend of mine to do some of the work on the plane. And he was out of town, so I had to deliver the plane to him. And he got the work done. I'm really pleased with what he did. He talked to me about it. But then I had some other priorities come up that just happened to take precedent and things I needed to get done. And basically, I haven't worked on the plane for a little over 3 months. But I am going to get back on track. In this video, this is content that I shot right before I had someone help me with the plane. And in this episode, I think I put on the alternator shunt, and the manifold pressure hoses to the ignition box. So with that, let's jump in and get building. I was going to work on the Ammeter shunt, which there's not a lot of directions on, and I started researching, but it looks like the alternator should go on first. And this is what they send you in the alternator bag. And I'll start researching and figuring out how this goes on. The first step in mounting the alternator is to get this bracket screwed into the holes. They give you a couple screws, and then they give you a connecting plate. I'm assuming that's kind of grounding the two. But that just screws up, and the long end gets facing forward. The next step is to just hang the alternator loosely. They give you a long bolt with a washer, and that's just attached to the wall. Everything's getting loosely fitted at this point just to get it set up. The next step is to attach this bar with a hole in the engine. There was some powder coating in here, so you had to kind of thread this with a wrench to kind of get that cleared up. And then this allows you to adjust the alternator. I did notice that all of these bolts have holes in them, so you can wire tie them. I don't know where you wire tie, so Tony Wall on project S21 project, he just drilled small holes in here and used the bar itself for wire tie. That seems like a pretty good idea, so I'll probably follow that same lead. I actually missed a bracket. There's a small bracket that goes onto the starter that comes across and attaches to this mount as well, so I'll have that. I drilled 2 small holes in this support brace. I think I used a 1/16 bit, and that allowed for the wire tie of the bolts. After drilling the holes in the, in the side plate, so I've got this one wire tied in here. These 2 are wire tied reverse direction. And this one will get wire tied as soon as I set the location for the alternator. I just heard back from the Plane Power rep, who is Plane Power is the maker of the alternator, and that little aluminum tab that's under here, I heard Tony Wall made a comment that it needs to be bent, and I didn't understand what I was bending it for. A quick explanation: he said it's an extra safety for these bolts. You bend it around the bolts. And he said if in case the safety wire gives or in case these come loose, that tab bent around the bolts. And he said he'll even tap it flush with the bolt after he bends it. That prevents the bolt from spinning around freely or undoing anymore. Okay, I've done some research on this shunt. So a shunt apparently measures electrical current. And you can measure the current from the battery, or you can measure it from the alternator, or you can do both. If you do it from the alternator, which is going to be my installation, you put this in between the alternator's B lead and your power source, and then you're going to attach 2 wires from the panel, which are then going to go back to the panel and measure the current from the alternator. So this gets mounted to my firewall near my starter solenoid, and I'm going to run an alternator cable and then a cable back to my 60 amp alternator breaker in my panel, and then I'm going to attach the 2 shunt wires from my panel on top of that, and that should measure my current. I'm going to put out, or I'm going to add a graph and some text from Kit Planes magazines that did an article on shunts. And they basically say there's 3 places you can put a shunt based on whether you want to measure alternator output in amps, the current draw of your panel, or battery charge and discharge rates. So the shunts can measure all kinds of stuff, and they show everything coming from the alternator, but then does it go to your master solenoid or your hot wire? Does it go back to your bus bar and your fuse box, or does it go both ways? So it says the most common use is shunt A, providing alternator output in amps versus the draw that your panel is taking, which would be B. So again, determine which way you want to hook it up. So to hook up my alternator to the shunt, I took some 8-gauge wire and crimped on some O-rings and protected them. I've got some boots coming also from, I think they're coming from Stein Air, maybe from Aircraft Spruce, but the boots will go up and around the terminal ends. I've hooked up my alternator wire. It's not secured down because I still have the boot that's coming that I'm going to put over here. I've run it under here. I am going to put an Adele clamp under, where am I looking? I'm going to put an Adele clamp here to get all this away. This is intake. The exhaust is out here. This is just intake, so it doesn't get as hot, but I still want to get it away from there. And then I've got it running to my shunt. And again, I'm going to get some boots on here. They're coming. And then from the shunt, I go up through my firewall, follow it back, and then it goes to my 60 amp alternator breaker in my panel. Now what I've heard is not every panel company puts a breaker in the panel, and if there's no breaker in the panel, you'll probably have a breaker on your firewall. So this is just one design, and then from here, so you get your current that comes in, it goes through the breaker, then it goes back to my bus, and that's how I actually charge my batteries, through the bus, which is unusual. You know, electricity flows like water. It is attached to the bus. It gets back to the battery. It's just not quite as direct. So this is the way the panel company designed it. Included with the alternator was this harness that plugs into the back of the alternator. This is for the power source to the alternator, which gets hooked up to the alt field or alternate field switch on the panel. So this gives you the ability to turn on and off the alternator. Boy, there's a lot of controversy and discussion about when to use the alternator on, alternator off. Do you start it with it on and off? When do you put it on? When do you shut it off? So read your own. I won't go into all of it, but there's a lot of procedure. If I want to shut the alternator off, I also have a 60 amp, which just by pulling that, I'd be shutting it off. So I've got a redundancy here. But again, this goes up. And then there's a second wire that lets you connect a alt-off light, kind of an idiot light that goes on your panel. So if you lose your alternator, rather than have to read a gauge, you would get this light like a low fuel warning. It's optional. Not everyone puts it in. You've got the indication in your panel, but this would just be an extra fail-safe light if you wanted to hook it up. So I took my alt field wire from my panel and attached it to the power wire from the alternator. And then I took the alt out wire, ran it through my firewall, and I just coiled it up and put for later use for an alternator out light, which I don't think I'll use, but I'll leave it up there just in case in the future. And now I need to run the 1 amp fuses, where's my shunt? The 1 amp fuses to my shunt, and attach those to my amp meter wires from the panel. I've got these two sensors, RPM sensors. I was only sent one wire on my panel, and the forum says, yeah, you really should have both hooked up. So my panel company was great. They wired me up a second wire, which goes into the GEA24. It gave me the pin number. Again, this is a little above my pay grade. I'd feel comfortable with someone having a little more experience doing this. So we're going to add that wire. We're going to try and install the RPM sensors. Okay, my friend from EAA was here, spent a couple hours, and set me up with, I think, a pretty good path on a couple of these items. First, there's a manifold pressure hose that runs from the manifold pressure sensor block. So right under here is my manifold pressure sensor block. So I'm going to put in this 90-degree fitting that's 1/8 MPT and then 1/8 hose diameter. I'm going to bring my hose over. Got to run it through my firewall. It'll come onto this side, and then it'll split into two, and with a splitter, and then one hose will go on this ignition box, and the other hose will go on the other side of that one. I was only supplied this much hose with the kit. This would reach the sensor to one ignition box, but to get it spliced and run it to the second one, I needed more. So I did order additional hose. This 1/8 inch Tygon hose showed up after I ordered it. This is all they gave me with a kit, and this is for the manifold pressure that goes to the ignition box. This wasn't enough to get through, so I did order some more. It's got a slightly larger outside diameter. It's more of a commercial grade. I don't think there's going to be a problem with that. And I decided to use an AN fitting for the pass-through. I'll probably cut it a little shorter, but I'll use this as my firewall pass-through. The rubber grommet just didn't seem to have enough fire protection, even though I think some cables go through the rubber grommet. The more unprotected pass-throughs that go through, the more problematic it could be with an engine fire. I connected my manifold pressure hose. I just used the extra port on this sensor bar, clamped it on to the 90-degree 1/8 NPT by barb, ran the 1/8 interior diameter hose, decided to use this AN fitting as a pass-through, and then it comes through, and then I've got a T barb here, so it tees down into this manifold pressure and then goes over and circles and attaches into the other one. I was also provided this harness which connects the two ignition boxes, and this is not going to be long enough. If you remember, like some other builders, I had to switch my boxes around so that the harness connections are on the outside, because these eyelets were blocking the harness connection on the inside. So I've ordered a longer one that will wrap around the top and connect it. I am not proficient with my soldering on these tiny little tabs without dripping solder and feeling like it's a good connection. So my harness company said they would do it for 1 hour's labor. So the Lightspeed manual says to run 2 independent wires shielded, bypassing electrical buses or the master solenoid to the breakers, the ignition breakers. My panel company only put 1 ignition breaker in here. So what I'm going to do is I'm going to put my second ignition breaker right next to the other one. And on the back side, this is where it comes through. And this connection, this bus bar here, I need to separate this bus bar here so that it's not attached to the bus bar, so that it's separate. So I've put together 2 wires and used the shield as a ground, which will go to my ground bus. And the positive side will go to the hot side of my solenoid. And then they run directly through. I had to re-thread them or snake them through my loom. I've brought them up here. I've done the positives will go to my 2 breakers up here independently, which I've cut the bar from the bus, so each breaker is independent. And I've got to put the second breaker in. I've got it. I've got to install the second breaker. Well, that's about where I finished working on the plane before I sent it away to be worked on. That section took 23.1 hours. That brings my project to date to 1,251 hours. As I said, my plan is to start working on it again. I want to have it flying in next year and get some more content out. So once again, thank you for watching, and remember, dream it, build it.